as we talked about earlier, we want to go ahead and dive a little bit deeper into what it means to be a zero of a polynomial, or to be a factor of that polynomial. So when we're working with these polynomials, they're going to have large degrees, such as 4, 5, 6, keep on going, right? And we don't really have any tools in our tool belt as of yet that we could solve for those x's, or solve for those x-intercepts. And the only thing we have is the quadratic equation, or factoring, which can be difficult, especially when you have such large polynomials, to factor them. And then the quadratic formula, I should say, only works for quadratics. So only polynomials with a degree of 2. So we need a way to find those zeros, or what we call our x-intercepts. So the tool we are now going to use is synthetic division. So let's go ahead and factor this polynomial into linear factors if -3 is a zero of f of x. Sorry, my board was coming off. Okay, so if -3 is a zero of f of x, what does it mean to be a zero? Okay, what it means is that when x is equal to -3, f of x is equal to 0, right? Crosses at -3 on my number line. Okay, that's where one of the points of where it crosses. Well, if I was to change this back into a binomial, I need to set it equal to 0. So how do I do that? I need to go ahead and add 3 to the other side to get a binomial of x plus 3 equals 0. So whenever you're given the actual number, that is the 0, you have to switch the sign and bring it to the other side to be able to divide by that polynomial. We're not going to use that -3 when we're synthetically dividing. We first have to change it into the factor, which is x plus 3. So let's go ahead and synthetically divide 6x cubed plus 19x squared plus 2x minus 3 by x plus 3. So this is what we're doing. We're taking that polynomial and we're dividing by x plus 3. So synthetic division, set it up. Take what you're dividing and just flip the sign. So this becomes -3. You can also think of it as you're just dividing by whatever your 0 is. You don't flip it. I think it makes more sense personally to me to flip it or change it back into a factor and then work like we've just been doing. So let's go ahead and take our coefficients, 6, 19, 2, and -3. We're going to synthetically divide, drop it down, multiply, add, it gets me 1, -3, add again, -1, multiply +3, adds to 0. Good, because when the remainder is 0, that means it does divide evenly, so we did that synthetic division correctly. It's a great checking tool. Change that back into a polynomial. So this is 6x squared plus x minus 1. Okay, so as we talked about in that last video, we've divided this, okay? So we've divided out x plus 3. So if we wanted to, taking the original function and break it up, it would break up into this polynomial times x plus 3. That would get us back to the original. But we want to actually keep going, so I'm going to go ahead and factor this guy again. Now, he is a trinomial with a leading coefficient, so I'm going to go ahead and use the AC method real quick. Actually, I'm going to use the slide and divide method. I think that's what I taught you guys a little bit before. But slide and divide, just take your leading coefficient, multiply it by your last one. So this would be 6 times -1 is -6. Factor it. Plus 3 minus 2 will multiply to get you -6 and add to get you +1. So then we have to do the divide part. So that was the slide. We have to divide by that leading coefficient of 6. Reduce, we get x plus 1/2 times x minus 1/3, just reducing those fractions. Take your denominator, multiply it on over. So this becomes 2x plus 1, 3x minus 1. So let's go ahead and rewrite that. Remember, we just factored this trinomial into 2x plus 1 times 3x minus 1. And of course, we also have to multiply it by that binomial that we factored out already, or we synthetically divided out. Okay, so this would be the factored form. So you could almost write factored form. Okay, that's what we're doing right there. So that would be your factor form. And it's completely factored. We can't factor anything out. And that is what you're trying to do. Now, we could set each of these factors equal to 0 and solve, which would give us the other zeros of 1/3 and -1/2. But that's not what the problem is asking us to do. It's just asking us to factor. So to factor, you start with one zero that you know, divide it out synthetically. And then if the result is factorable, we're going to go ahead and factor that baby. We get our final factored result. Okay, now what if we don't know what the zeros are and we need to have a starting jumping off point? Well, we can actually use GeoGebra to graph our function and identify those zeros. So that's what we're going to do. So let's go ahead and graph this function here. So just on the bottom of the screen, I'm going to type in f of x equals 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus, 2. Okay. Hit enter. Double check that I typed it in correctly. You can even expand that. Okay. So we want to zoom in a little bit and we can see a couple things. It looks like where this graph is crossing the x-axis, those are our zeros, it's going to be at -2, -0.5, maybe like a -0.5. I'm not sure. That could be 1/3. It could be something a little different, not 100% on that one. And then 1. So I'm going to go with the ones that I am sure, like -2 and +1. I can even plot a point there, and it does tell me that there is a 0 at -2, and there is a 0 at 1. And the other two I'm kind of guessing at, so let's just do the -2 and the +1 for right now. So we're going to start with a 0 of +1. The ones are always easier to start with, right? Okay, and we want to go ahead and divide that out. So first we have to change it back into a binomial. So if x equals 1, then we got to go ahead and subtract 1 to the other side to make the binomial that we're dividing by x minus 1. So let's go ahead and synthetically divide out x minus 1 to begin. So start here. Okay, what are we dividing by? X minus 1. Flip the sign to a positive. Take your coefficients, 6, 7, -12, -3, and +2. Write them underneath. Start your synthetic division. Drop down 6, multiply by 1. We've got 6. Add down, you've got 13. Multiply. Then add down again. Multiply again. -2. Multiply. -2 is 0. So that means, good news, we've factored it correctly, and it does factor evenly. So this leaves us with 6x cubed plus 13x squared plus x minus 2. So that's what's left over, and I want to remember what I factored out here. So remember I factored out x minus 1. So I want to write what I factored out next to it because I'm trying to factor these. Okay, now we can keep going like that. Another 0 that we had was -2, right? That was on there. So x equals -2. Again, write it as a binomial by adding it over. So x plus 2 would be your binomial that you need to divide by. So we're going to just take this one and divide by x plus 2. Don't worry about this x minus 1. It's just a factor that's hanging out there right now. So let's continue this. So we're going to go ahead and synthetically divide. So we're dividing by x plus 2. Flip the sign to a -2. Take your coefficients and write them underneath. 6, 13, 1, and -2. Drop down, multiply. It's like a little dance after you've done it enough times, right? 1, multiply, add down, multiply, that becomes a +2, which zeros. Yay! You can even draw smiley faces if you want to. And so the resulting polynomial is 6x squared plus x minus 1. And just as a reminder, that was what was left over, but let's go ahead and multiply by not the factor that we were dividing by, which is x plus 2, but also the other factor that's just chilling out there. So the other factor is x minus 1, excuse me. Okay, so we want to factor this guy. I'm going to go ahead and just quickly factor him. I believe we just did this, so. Yeah, we literally just did this one. So apparently I wasn't too creative with that. Let's see, +1, -1. Yep, okay. So the cool thing is that once you use synthetic division to divide out a couple of those factors, you come down to that trinomial and you can go ahead and just use those tools that you already have in your bag to factor the resulting and leftover trinomial. So that means you have completely factored your polynomial. And what you can do is just set each of these factors equal to 0 and find all possible zeros. So we know that the zeros are 1, -2, right? We synthetically divided to show that those were the negatives. If I had set 2x plus 1 equal to 0, that would be -1/2, which matches up to our graph that we showed at the beginning. And then our last one is set that equal to 0, gives you 1/3, +1/3, which does match up with that graph. We have found all 4 of those possible zeros. So remember, when you're trying to find zeros, graph the polynomial. Start with a couple of the easier zeros. Synthetically divide those out to show that they are factors. And then once you get down to a trinomial, you can go ahead and use your factoring techniques to factor it even further. And then the resulting factors will give you your zeros as long as you set them equal to 0. So try that out. Use GeoGebra as a helpful, handy little tool there. And let me know if you do have any other questions.